Bismillah ar-Rahman ar-Rahim. This students is our first lecture for the networking in Java. Okay. Um, what's computer network? Basically, computer is interconnection of collection of autonomous computers. What we call as hosts sometimes. Okay. So what our network includes is a special purpose hardware devices that basically interconnects transmission media, that controls transmission data, that runs protocol software. Now, protocol software are that encodes and formats data, detects and corrects problems, and counter during transmission. Now, our network has some architecture, okay, and a network architecture is a set of layers and protocols used to reduce network design complexity. You'll be reading those things in a networking subject, which is a full-blown subject on networking. So we're talking about here just a couple of TCP protocol suite. We got OSI, Open System Interconnection. That's again a suite protocol. That's again a protocol suite. Okay. Now, if you generally talk about this is the end host. This is another host. Applications generated in the application layer. They got a presentation layer. We got session, transport, network, data link, and physical layer. Now, in application, basically there are various applications: FTP, HTTP. You can have a mail. You can do a lot of things here. And then presentation means which presents data in meaningful format. Okay, then session provides sessions, session semantics. Transport layer is a reliable end-to-end byte stream. Okay, transfer, and here network layer is an end-to-end transmission of packets, and then we got the data link layer, which is basically transmitting frames, and the physical layer we got transmission of raw bits. So these layers are actually, why we have these layers is about what's called as the abstraction, to hide the complexity. So that's why abstraction actually leads to the layering. Okay. Now, Internet Engineering Task Force defines the internet architecture as an hourglass design. Now you could see here we got an application layer. We have a lot of services going on like FTP, HTTP, NV, TFTP, and so on. And downsides, we got a couple of transmission technologies like TCP or UDP. We'll talk about more. Then we are in the network layer. We got IP, and then there are many networks which are the data frame, data link layer. We talked about a lot of frames, a lot of networks going on here. This is called what's called an hourglass architecture. Now, when we try to connect two guys, we basically have two types of communications. Either is a connection oriented or is a connectionless. In a connection oriented setup, the link before communication, like we have a phone call, we need the phone number and receiver. Connectionless, no link needed to be set up before communication. Similarly, similar to send a letter, we need the address and receive. Now, when we are talking about the computers, there's also one more classification of exam with the client and servers. So basically, we have servers and we have clients. Okay. Now, your server, your client can access something from a server and request something from a server, and server actually serves that request. Now, if we have only one service going on, then you can serve only one server. But what we do is we logically divide the address space into what's called the ports. Before we talk about the ports, we need to talk about the 4-byte IP address. Okay, this is a unique. This is typically written in a dotted quad format, like we know, where each byte is an unsigned value between 0 to 255. Now, this representation is not user friendly, so we need to have basically some contents. It's difficult to remember these dotted quad format. So that's why IPRS are mapped to some names. Like we got www.google.com, but basically on the back we have the address like that, dotted quad format. It's the DNS which actually maps things between these two, right? if we run a ns lookup cmd, then we'll run ns lookup, and I'm saying google.com. Now it's telling us all the IP addresses which ns lookup google.com has. So if you look at here, these are the 1, 2, 3, 4 octets. Okay, and these are all the IP addresses of the Google servers. So if you plug in this thing in your URL box, it will land you to google.com. Or if I say like google.co.in, now these are the addresses of our this is the MAC address, then this is the IP address of your google.co.in. Now this google.co.in, so if you write this thing in your URL, it connects to the DNS basically and gets this address, then it's back sent to your browser, and then you will connect. Or alternatively, you could have said you could just simply, if you open up the browser, now this is my browser, and if I plug in here say 173.194.40.120 and just give it a go, and I have a slow internet this time, there's a lot of downloads going on, but it will land you to the Google page. Say for example it was not this thing, because the Google page is already by default in the Google Chrome, but if I say like YouTube, now it will go to some YouTube search. Okay, now if I say any address, and say another address I have 173.194.40.127 for example, and I give it a go, it will land you to the google.co.in page. As you can see here, it's getting to www.google.co.in. So basically your addresses, which are like URLs like these, but actual addresses are the IP addresses. And to know more about IP addresses, you should refer to the networking classes. But now the problem is that if you have a particular network address, okay, and let's see here, you got a one network address, then that means you can have only one service going on. What we do is we divide our application addresses logically inside into many ports. Now what ports are? They're actually logical addresses which actually tell us which application is running, which application you want, or which service you want. Now IPRS is 4 byte or 32 bits, okay, but your what's called as this ports are 16-bit. So how many ports you can have? I have one of the apps developed in a VB, and let me go to desktop, call it PAR something. Yeah, power 2. Now you can write here 16. You've got 16 bits. So how many address you can generate is 65536, or because we start from 0, so it's 0 to 65535. So these much of ports we can have, right? So what we're talking about is we have got only one internet address, that's IP address. But however, computer often need to communicate and provide more than one type of services or talk to multiple hosts or computers at a time. For example, there can be multiple, these things, multiple FTP sessions, web connection, chat program. They must be all run together. So distribute between these services, we have a concept of ports, a logical access point. It is built by 16-bit integers. Okay. That means each service offered by computer is uniquely identified by a port number. So port number is a logical address of a service or an application running in the top layer of the OSI model. Okay, that's the application layer. You can also put up your firewalls here, for example. Say for example your HTTP is having a port number 80, or if you want to stop that, you can have a firewall that stops this port. There's one more thing what's called as a socket. Okay, basically application layer is having a socket which is run through the UDP or TCP, and then to the IP and to the Ethernet, and then to the router to the next channel, and so on. The sockets can be at the TCP socket or UDP socket. We'll discuss the TCP, UDP, and more, and so on. Then the sockets are actually bound with the ports, and then to the IPRS. What is this socket all about? We'll discuss this now. Okay, we're talking about that every like FTP or HTTP, any service or any application basically has a port to identify that. And now we have a TCP linked to that port, or a UDP linked to that port. Okay, which are basically two major transport layer protocols. Before we discuss them, let's discuss the socket. Now, socket, we have got a socket. What socket is basically, it is linked with the IP, the combination of basically the IP and the protocol, and also either TCP or UDP, and then the port to identify the perfect connection, for this machine. So if we want to connect to the particular machine, and we have an IP address to connect to that machine, okay, but in a particular machine there are a lot of services going on through a couple of protocols, at least TCP or UDP at transport level. So you have an address, but unless you don't know whether you are using TCP or using UDP, and then for example you are using TCP, and then if you don't know what is the port, then you may not land into the particular application which we're talking about. So for example, HTTP port number 80, right? So the combination of what I can say, the perfect address of an application or of a machine to interact with. So for example, your web browser is having an HTTP. You not only need, say for example, your client asks to the server, but when the traffic comes up, it has to know the IP of that machine. Then the TCP protocol, which protocol we're talking about, and then also the port number. So combination of all these three is called basically a socket. So a socket is defined as the endpoint of communication. Basically, it's concatenation of IP address and a port. Okay. If you have connection oriented, that means if you have TCP or you have an IP or UDP, connectionless, there's a phone number and a receiver, and in case connectionless and a UDP, you will address and a receiver. Okay, so a socket pair, local IP address, local port, and then foreign IP address, foreign port. You need identifies communication because you got a two-way, on one side and another side, socket to socket. Okay, if you got a like this, so it's basically the IP address, and 1625 is the port on the host. We can see we have an external command in the Windows called netstat. We'll just see that. Put in this netstat. Okay. Now it's coming up. It's telling me the links. Okay. What we have here this time is 127.0.0.1. Now port number this 49156. We'll talk about the 127.0.1. It's called as localhost also. We'll talk about this later. What's happened to that? What is gone? And again, netstat. Okay. Now this is the IP address, and this is gonna be the host. Now these are the IP addresses, and these are the host. Do you understand? Okay. So using the netstat, we can just see what kind of ports we have and what kind of IP addresses we are linked to and all that. So we're talking about a socket in a client, basically a lot of ports, and it acts like a channel where you send the message. Okay, so basically you got two protocols in the transport layer, which is TCP and UDP. Transmit control protocol is a connection oriented protocol, and UDP is a different protocol. It is a connectionless protocol. Now basically we have usually in the we have got a client and server architecture, and we just saw the application layer and transport layer, the two important these guys. One is a transfer control protocol, and then there is another one is the UDP, that's user data protocol. So literally you got a TCP or UDP, and then we're gonna port that's gonna be what's called as a socket, and because on one side you got an app, okay, and you have a data which has the port and the data basically. Now where exactly the socket lies? Roughly speaking, socket lies in a session layer, okay, because the session layer provides services for managing and controlling data flow between two computers. As a part of this layer, sockets provide an abstraction that hides the complexities of getting the bits and bytes on the wire for transmission. In other words, socket allows us to transmit data, having our application indicate they want to send some bytes. Sockets mask the nuts and bolts of getting the job done. So basically it's all about abstraction, you know. So this is what we're talking about. So when you're writing a code using sockets, that code does not work at the presentation layer, okay. That code actually works at the presentation layer, because presentation layer provides a common representation information that application can use. Now actually you're writing your Java app, that's an application layer. The presentation layer has to do the transmissions from one to the other. For example, you are planning to connect your application to the legacy banking system that understands only ABCDIC code, okay. Your application domain object stores information in ASCII format. So in this case, you're responsible for writing a code in the presentation layer to convert data from ABCDIC to the ASCII, and then, for example, to provide a domain object to your application layer. Okay, your application layer can then do whatever it wants with the domain object. Okay. So the socket handling code you write lives only at the presentation layer. Your application layer does not have to know anything about the socket work. So what is the socket all about? So it's a software abstraction used to represent the terminal of a connection between the two machines. For a given connection, there is a socket on each machine, and you can imagine a hypothetical cable running between the two machines, with each end of the cable plugged into the socket. Of course, the physical hardware and the cabling between machines is completely unknown. The whole point of abstraction is that you don't have to know more than is necessary. Now, in a nutshell, a socket on one computer that talks to the socket on another computer creates a communication channel. Now, a programmer can use this channel to send data between the two machines. So when you send data, each layer TCP IP has its own headers and trailers and all those things. Okay, but the good thing is that Java language hides all of this from you by providing the data to your code on stream. So your data to your code is on streams, that's why we usually call them the streaming sockets. Okay. Now sockets, generally speaking, come in two flavors. One is a TCP socket implemented with the socket class, which we are going to discuss, and the UDP socket implements the datagram socket. So there are two kinds of sockets. You know, even though the Java networking APIs enable you to open and close network connections via sockets, okay, but all communication happens via the Java IO classes, that's input stream and output stream. We should remember this point. Now, if you wanna over Java networking, the first thing is we have a number of classes and packages to support writing internet-aware program. So what are these class and packages? Before that, we just discussed with socket about a directional serial communication channel that associated to network connected computers, and server and client we know. Then we know IPRS, okay, domain name, port, URL, host name. Now we know we have an IP address and we have got the domain name. So what is in the Java for that is called the inet address. This is a class used to enclose both numerical IP address and the domain name for a particular address. Okay. So to create an object for class IP address by using the name of an IP host or IP address. Okay. Now IP address is more suitable and understandable than IP host. It hides basically the number inside IP address. It doesn't have a constructor to create an object. Okay. Through its factory method, it creates its own object. So these are the factory methods of the AndroidAddress. That's like get localhost, get by name, it will return the localhost, okay. Get by name, it returns the IP address, the given host's name. You put the host's name here, it will give you the IP address of that. Get all by name, string host, returns an array of IP addresses based on the configured name servers on the system of given host. We'll just try our hands on it. Important thing is, if they are unable to return the host name, they throw an unknown host exception. So let's try our hands on it. Now if you look at it, before we did anything, we need to actually got java.net .star basically here, I should say. Simply I will say java.net .star because I need a lot of things from it, okay. So java.net has this package is everything for the networking support we need to have. So we need I'm creating an InetAddress IA, and I'm saying get localhost. So it will give me the actually the name and IP address, basically both. So this guy get localhost will give me the IP and the name of the host. Actually, it's a localhost. So that's going to be my machine and its IP address. Then I'm outputting that. Then I'm creating an array of InetAddresses, and it does not have a new method and doesn't create any object, and although it is a factory methods where it gets its instantiation. So InetAddress dot get all by name is where we use the some host name, whatever it is, and it will tell us all kind of what kind of addresses it has and what kind of host name and IP address pairs. All those things will be put up into the IAD, and then you can output that. Simple as it is. Now give it a go. As you can see, first thing is, if it's coming in not in a recorder, it's a Jenny PC, the name of the my local host, and then its IP address 192.168.1.35. Then it's showing me the google.com's IP addresses. Okay, do you understand? The next thing what we have is called as a socket class. Okay, a socket can be used to connect Java's I/O system to the other programs that may reside on the local machine or any other machine on the internet. Now there are two kind of sockets, TCP sockets in Java. We have one is a server socket and one is a client socket. And the constructors we have is a socket. We get a couple of constructors which gives a string host name and input. So that it creates a stream socket, creates basically a stream socket, and connects it to the specified port, which is here on the named host, whatever the host name is. And similarly with another, where we give the InetAddress and input. That it creates a stream socket and connects to the specified port number at a specified IP address. Okay. Here we give the host name. Okay. Here we give the IP address. Now there are methods. There are many methods to examine the socket class, which provide information basically about the address and the port connected. That's one of them is the get InetAddress, get local port, and get port. Get InetAddress returns the address to which the socket is connected. Okay, and local port returns local port to which the socket is bound, and port basically get port simply returns a remote port to which the socket is connected. So once the socket object has been created, it can also be analyzed to gain access through the method input and output stream associated with it. Now these are the methods like get input stream. It returns the input stream for the socket. Okay, and get output stream returns the output stream for the socket, and closes both input and output stream. Now I'm using a method called get by name. Okay, it returns the InetAddress or whatever you put up here. If I give it a go, it puts the InetAddress is a combination of name and the IP address, right? What I'm saying is we created the InetAddress, okay, and I'm talking about because if you wanna just don't need this now. If I wanna do what I am telling you, okay, just Control C. You put up there. What is this IA? We have just seen that what's IA. InetAddress of this we can get by the name because it will tell you the exact IP address, because the socket needs two things. One is the IP and one is the port. Okay. So socket is exactly the proper way we have to feed the IP address is to have the InetAddress, because in Java the addressing of a machine is being taken in the InetAddress. As you can see here, this class InetAddress represents Internet Protocol IP address. Simple way is that you should be reading all these things to get acquainted. But what I'm telling about is this IPRS is IA is all about IPRS, and a socket we need two things. One is the IPRS and one is the host. Okay, so I told you in the before video that the socket actually is a combination of a whole bunch of things, like the IPRS is like the which protocol suit to TCP or UDP and which port, so that we can exactly have a proper connection, a proper channel to the particular application running in a particular machine. Okay, now I'm connected to this google.com, so there will be on a server side, on a client side. So google.com is our server side. It has its own port and it has its own IPRS, and we may have our machine has our own IPRS and our own port. So firstly, I am trying to check about is the IPRS with socket. That is, I'm saying get INET address. So what is the INET address of the server google.com, right? So let's try to see this and run this. The first one is it's the IA INET address, that is the domain name, and the IPRS, that is this thing. Now IPRS is socket, that is www.google.com. This is the same thing basically, which is telling us what it is. It is exactly the same thing which IA has told us, so we can get back that IP address here by saying get INET address. Okay, which IP address is with that socket 80 basically. So this is the get INET address. You can get back towards the INET address in this socket, right? Then now after that, I want to see which port this guy is linked, so I may say get port, and if you see it returns the port number to which this socket is connected. Okay, so you can just see that I'm just putting up this. Now it will tell us which port, and definitely it's going to be 80 because we have talked about 80, so port is 80, right? Okay, now this is on the server side where the Google lies. What about our local side? Now what I'm telling you is, if you want to know now the local port, okay, it's the local port number to which the socket is bound. Okay, so that means of this machine. What is the local port of this machine? Okay, because now we are bound into the local port of the machine, which is the local port of our machine. That's 50766. This is gonna be the local port of this machine, right? Control Alt down arrow. Now I may say after local port, I may say local socket address. Local socket address. What is the local socket address? So sc dot, what I need to have is get local socket address, right? Get local socket address. Now local socket address is, this is our socket address. So the socket address is complete. One is the IP address 192.168.1.35 is my IP. That's the thing. It's gonna be the my IP, and this is gonna be the my port to which this program, because this program is running on the application program, is running, okay, the Java program in the application layer. Then a session will be connected with will be created with the google.com. It's port number 80 on this IP address, and we are linked to this using our 50768 port. Okay, we just saw this is our local socket address. Okay, now there are a couple more things. One is the input of socket, output socket. We have get input stream and get output stream. We will talk more about them in some application we'll see. So we have the input socket is java.net socket input stream at the whatever. This is the errors of that, and this is the output stream. And these are the all methods. There are many more, like get in INET address, port, local port, and local socket. So local port, local socket is this machine, and where from we are fetching, that's the google.com is the get its INET address and its port. Then if you wanna read something or write something to from these guys, then I need an input stream and output stream, and when link it to the socket, the socket has these things we just saw, and we'll see a concrete example, mechanical example, where all these things will be used. Before that, I must say that we should also close our socket before doing anything. sc dot close. Okay, this is how we close the socket.